MCP3008 is an 8-channel analog-to-digital converter using SPI interface and is popular for use with Arduino Uno and similar microcontroller units. The connections are well documented, and libraries for interfacing MCP3008 and Arduino are readily available. However, the maximum sampling speed that can be achieved so far is only 60 kilosamples per second, as documented on this article. And one of the reasons for that is that manufacturer recommends the following communication with the microcontroller units. It consists of 3 bytes with the 7 first bits being just zeros and the last bit being so-called start bit. And then you have 2 bytes of transfer that sends what we want to get and getting back the results. However, this means that 7 bits are pretty much a wasted time that reduces the sampling speed. In this video, we are going to rearrange this transfer to achieve up to 130 kilosamples per second while reading minimum and maximum and optionally the average of the signal using an Arduino Uno. So what I propose is to skip all those 7 bits completely and just start with the transfer of the start bit 1, 2, 3, 4, 5, 6, 7, 8. That's the first byte, and then proceed with the second byte 1, 2, 3, 4, 5, 6, 7, 8. And what you notice that the last bit is not being transferred at all, but that shouldn't be an issue, because if you look at the clocking diagram over here, at the end of the 23rd bit, the chip is already showing us the value that we can read directly using the direct pin manipulation on the line connected to the D out. And this is what we are going to do. The program consists of 2 parts. One is the class that is providing the communication, and the second is the example program that reads in the values and reports minimum, maximum, and optionally the average. So first we will talk about the class fast MCP3008. It has a few public functions. One of them is initialization, which is mostly just SPI class initialization. It also allows to set the clock divider either to enable 4 MHz on the SPI bus or 2 MHz if you do not want to overclock the chip. Second function is getting the channel mask, which is basically providing the channel which you want to read from 0 to 7, and it will return the channel mask that can then be used in the read function that does the following. So what we need to do is to first enable the chip by pulling the CS pin low. This is done by this command here. Then we transfer the channel mask. Then we transfer 0, collect the results, and last but not least, we also need to read the contents of the D out pin, and that's what we do with this command over here. After this, we pull the CS pin high, turning off the chip, and return the data. All we need to do is to get our result, shift it by one bit, and then add the last bit that we read in this command, and return the first 10 bits of this number. And this is it. This is the minimum transfer that will get the job done. So now for the example, it's very simple. We create an instance of the class FastMCP3008. We set up the serial port to output the results and initialize the ADC instance. Our experiment that we run in a loop every 2 seconds. We ask the chip to provide 100,000 measurements and then collect the minimum and the maximum of those values. And also optionally, if we enable the doCalc_avg macro, we also collect the average. This is presented in this block, how we fill in the value of maximum, minimum, and the average once we get the current value from the ADC. After the experiment is done, 100,000 values are read. We report the results to the serial port. Wait for 2 seconds, and then the loop function repeats itself. So what we're gonna do now is just to show how this works in practice and what kind of speeds I achieved by this procedure. Here is an example. MCP3008 over here is connected to the Arduino Uno, and I have the sketch uploaded. And what we have is minimum, maximum, and average reported for a potentiometer set approximately to the middle position. So we get around 510 on average, 509 minimum, maximum 511. If I rotate the potentiometer right now, you will see the figures changed. And we have around 892 milliseconds for 100,000 samples, which will mean, if we do the calculations, that we need to have 193 milliseconds, so, and divided by 100,000, that will give us about 112,000 samples per second. The second experiment, I comment out the doCalc_avg macro, so we are only going to get minimum and maximum, but we are going to have increased samples sample rate, because Arduino Uno will have less time spending on calculating things and will spend more time sampling the ADC. So let me just press Ctrl U to upload the sketch. And our time got reduced to 723 milliseconds. And if we do the calculations, 723 divided by 1000 and divided by 100 1000 will give us about 138 kilosamples per second. Here you go. We demonstrated that we can sample at rates that exceed 110 kilosamples per second using an Arduino Uno. But this coin has two sides. On the downside, you have to use buffering to provide the signal to the ADC, because with sampling that fast, the precision can only be achieved by using low impedance sources. So you have to look up how to create a voltage follower and make sure that you minimize the noise in the system coming from the digital side. We tried to use 4 MHz SPI bus frequency, which worked fine, and it's a little bit bigger than recommended, and you can see that in the datasheet that as each conversion takes 18 clock 18 cycles of a clock. So that would correspond about 220 kilosamples per second for the MCP3008 itself. So you wouldn't get the best precision, but still it's not that bad. Maybe for your purposes it's good enough. If you want to increase the precision, you would have to try either at 2 MHz speed, which will put you in this region, which is perfectly fine. But if you still want to sample fast, you might want to figure out how to run a standalone Atmega 328P with a reduced frequency, about 14.5 MHz, so that the quarter of it will be around 200 kilosamples per second in the recommended range for the MCP3008. But other than that, it's a successful project. I put the examples on a GitHub account, so you can check it out, download, see if it works for you. Any comments, suggestions, maybe some workarounds for problems that you encounter are greatly appreciated. That's it for now. Bye.